Hello viewers, let's solve this nice quadratic equation problem now using what we call the VIETA'S formula. Okay, now I made a video 2 days ago about VIETA'S formula. So now, and this question was sent to my mail, okay, to solve. So now we have this question. Now, the question reads, given that alpha and beta are the roots of the equation 3x squared plus x plus 2 equals to 0. That is a quadratic equation. Now, we want to evaluate 1 over alpha squared plus 1 over beta squared. Then also to find an equation whose roots are 1 over alpha squared and 1 over beta squared. Now, the third question here is, what is the one that we have to show that 27 alpha to the fourth, to the fourth power is equals to 11 alpha plus 10. Now let's see how this can be done. Now the first thing is, let's recall the VIETA'S formula, for a quadratic equation. That's for solving quadratic equation. Okay, let's have our solution. Now, let's recall the VIETA'S formula. Okay, the VIETA'S formula for a quadratic equation. Okay, that's a quadratic equation. Ax squared plus bx plus c equals to 0. So now, for this equation, that is the general quadratic equation. We know that to use the VIETA'S formula, okay, now we will need to find the sum of roots and the product of roots. Of course, this is the associated equation in this. Now, for this question, that is, we are given 3x squared plus x plus 3 plus 2 equals to 0. All right, so now the roots. Now, let's say the roots of the equation. The root of the equation are alpha and beta. Okay, so we have the sum of roots. Okay, the sum of roots to be alpha plus beta, which is negative b over what? A. Now we also have the product of roots. Okay, we have the product of roots. Okay, product of roots is the what? Product of alpha and beta, and that's what? C over A. Of course, there are proof, there are proof for all of this, okay? That is using the VIETA'S formula. So like I said, sum of root is negative b over A, then product of root is alpha times beta, which is the product of alpha and beta equals to C over A. So now let's see how this can be applied to this question. Now, we are given the equation. Now we are given 3x squared plus x plus 2 equals to 0. Okay, now the first question here is to evaluate 1 over alpha squared plus 1 over beta squared. But now the first thing, now it is important for us to first find the sum of roots, for the given equation, and also the product of roots. So in this case, the sum of roots, okay, that is SOR. Okay, the sum of roots would be, now here we have negative b over what? A. Now we know that A will be what? 3. Then B will be what? 1. And C will be 2. That is when we compare this with the general quadratic equation. This is the general quadratic equation. Okay, now, so sum of roots would be, now we have minus b over a, that will be minus 1 over 3. Okay, then for POR, okay, which is the product, we have the product of root. The product of root, that will be alpha multiplied by beta. Okay, so for product of roots, that's C, okay, which is 2 over what? A, that will be 2 over 3. That's 2 over 3. That's C over what? A, that's 2 over 3. So we have the sum of roots and the what? And the product of roots. Now we want to evaluate 1 over alpha square plus 1 over beta square. So Roman numeral 1. Okay, Roman numeral 1. Now to evaluate to evaluate 1 over alpha square plus 1 over beta square. Now, the first thing to do in this case is to simplify the expression. So after we simplify the expression, then we can now plug in the values for sum of root and product of roots. Now, let's simplify this. Now, to simplify this, we are going to get, if we perform what we call algebraic multiplication, we're going to have alpha square plus beta square over square of alpha and what? Square of beta. Now, one of the algebraic identities, when we have sum of squares, okay, sum of squares, that's sum of two squares, okay. So for sum of two squares, okay, we know that if we have a square plus b square, okay, this will be a plus b to the square minus 2ab. Yes, that's sum of squares, okay. That's the sum of a square and b square will be equals to the square of the sum of a and b, okay, minus 2 times the product of a and b. So now we're going to apply that in this case, that's sum of two squares. So which means for alpha square plus beta square, okay, for alpha square plus beta square, that will be alpha plus beta to the square raised to the power of 2, then 2 times alpha times beta. That is 2 multiplied by the product of alpha and beta. So we're going to what? We're going to replace this with this expression. Okay, so remember I said this is what we call sum of squares. Sum of squares, okay, sum of squares. So what we have here is alpha square plus beta square over square of alpha multiplied by square of beta, and that will be alpha plus beta to the square raised to the power of 2, okay, 2 alpha beta all over. Then we can also write this as product of alpha and beta raised to the what? To the power of 2. Okay, then so which means for this expression, okay, for this expression, we just simplify this expression to be what? To be this. So we are now going to plug in the values, okay, the sum of roots, which is -1 over 3, and the product of roots. So we have alpha plus the square of alpha plus beta minus 2 alpha beta over alpha beta to the what? Raised to the power of 2. So alpha plus beta is -1 over 3. So we have it raised to the power of 2 in this case. So we have -1 over 3 raised to the power of 2. Then 2 times the product of alpha and beta, which is product of roots, okay, that will be 2 over 3. So we have this to be 2 over 3. Okay, then over, now the product of alpha and beta is what? 2 over 3. So we have 2 over 3 raised to the power of 2. So now let's simplify this. Now we know that the square of -1 over 3 is what? 1 over 9. Okay, then plus 4 over 3. Then all over 2 square, that's 4. 3 square, that will be 9. So this will be, now when we simplify this, this will become that will be negative, it is going to be 3 minus 4. Oh, sorry, that will be 1 minus 12. That will be 1 minus 12, okay, then all over 4 over 9. All over 4 over 9. So 1 minus 12 is -11 over 9. So when we flip the fraction, that's when we flip the fraction, after we change the division sign to multiplication, this will be 9 over 4. So this becomes -11 over 4. So which means 1 over alpha square plus 1 over beta square is equals to -11 over what? Over 4. -11 over 4. -11 over 4. And that's for Roman numeral 1. Okay, so for Roman numeral 2, we want to find an equation whose roots are 1 over alpha square and 1 over what? Beta square. Now, the sum of roots, okay, to find an equation, let me write it this way. To find an equation whose roots are 1 over alpha square, and then 1 over what? 1 over beta square. Now we know that the sum of roots, okay, is the sum of 1 over alpha square plus 1 over beta square, okay, is what we have here as negative 11 over 4. That is 1 over alpha square plus 1 over beta square. Okay, that's what we have as 11 minus 11 over 4. Now let's do the product of roots. So we have the product of roots. That will be 1 over alpha square multiplied by 1 over beta square. Okay, and that's 1 over, now the square of alpha times beta, that will be that's what we have as 2 over 3, and which will be 4 over 9. Okay, so we now have 1 over 4 over 9. So when we flip the fraction, we're going to have 9 over 4. That will be 9 over 4. Now, to form a quadratic equation whose roots are 1 over alpha square and 1 over beta square, after we found that the sum of roots is minus 11 over 4 and the product of roots is 9 over 4, we can just use this, equation where we have alpha square, x square minus sum of roots, okay, x square minus sum of root of x, then product plus product of roots, okay, equals to 0. So we are going to plug in this value. So we have the first one to be x squared. Now the sum of root is minus 11 over 4 of x plus the product of root, which is what? 9 over 4 equals to 0. Now when this equation is multiplied, when we multiply this equation by 4, then we're going to have 4x squared positive 11x plus 9 equals to 0. And this is the what? This is the equation whose roots are 1 over alpha and 1 over beta. Okay. Now, about the third question, here we want to show that 27 alpha raised to the fourth power is equals to 11 alpha plus 10. 11 alpha plus 10. So now, this means that the only root which satisfies this equation is alpha. So since alpha is the only root of this equation, so it means we can set x equals to what? Equals to alpha. That means x will be equals to alpha. So now we want to show that 27 alpha to the fourth equals to 11 alpha plus 10. Okay, alpha is the root. Okay, alpha is the root which satisfies the equation 3x squared plus x plus 2 equals to 0. So which means we can say that x equals to alpha, so that this will be 3 alpha squared plus alpha plus 2 equals to 0. Okay, so now, so this is what we're going to do. Since we have 27 alpha to the fourth power equals to 11 alpha plus 10. So let's do it this way. Now let me move this to the other side, so that this will be this is going to be 3 alpha square equals to, so I'm going to move this to the other side, minus alpha minus 2. Okay, now because we need to express alpha raised to the power of 4 in terms of alpha, because alpha is the only root which satisfies the equation. So let's multiply this. Let's square both sides. Okay, let's square both sides. Okay, let's square both sides. Okay, take this raised to the power of 2 and this raised to the power of 2. So when we square both sides, okay, we are going to have 3 alpha square raised to the power of 2. Then the square of negative alpha minus 2 raised to the power of 2. So this is going to be 9 alpha raised to the power of 4. Yes, raised to the power of 4. So if we expand this is going to be alpha square, okay, then we're going to have 2 times negative alpha multiplied by 2. That's going to be positive 4 alpha, then plus 4. Yeah, plus 4. Plus 4. Yes, that's plus 4. So now, from here, we know that from this equation, now from 3 alpha square equals to negative alpha minus 2. Now we know that alpha square will be minus alpha minus 2 over 3. Yes, minus alpha minus 2 over 3. Minus alpha minus 2 over 3. So what we're going to do is, now let me continue from here. So now we're going to what? We're going to substitute minus alpha minus 2 over 3 for alpha square, okay, in this equation, okay, in this equation. So now this equation is very important, okay. So now, let's substitute. Now from there we have alpha square equals to negative alpha minus 2 over 3, okay. So then I said substitute negative alpha minus 2 over 3 for alpha square in this equation. That's in 9 alpha raised to the power of 4 equals to alpha square plus 4 alpha plus 4. So that will be, so what we're going to do now is when we substitute for alpha square, so we have 9 alpha raised to the power of 4 equals to negative alpha minus 2 over 3, okay, then plus 4 alpha, then plus 4. So we can now multiply the equation, that is this equation, by 3. So when we multiply the equation by 3, we're going to have 3 multiplied by 9 alpha raised to the power of 4, then 3 multiplied by negative alpha minus 2 over 3, then plus 3 multiplied by 4 alpha, then also plus 3 multiplied by 4. Okay, so this will be 27 alpha raised to the power of 4. Now this will cancel out, okay, so this will be equals to negative alpha minus 2. This will be plus 12 alpha, then plus 12. Okay, so now, yeah, this is correct. Okay, so we now have 27 alpha raised to the 4th. Okay, 12 alpha minus alpha, that will be equals to 11 alpha. Then 12 minus 2, that will be equals to what? 10. So which means 27 alpha raised to the power of 4 equals to alpha plus 10 is equals to alpha plus 10. And we just prove that, okay? Okay, we just prove that 27 alpha raised to the 4th is equals to 11 alpha plus 10. And that's what we have here. The noblest pleasure is the joy of understanding. Bye-bye.